Okay. So, uncertainty usually means we don't know, but in quantum physics, uncertainty is something we can exploit, which allows things to be in two places at once. So uncertainty is intrinsically linked with measurement. When you measure something such as an object's position, you expect to pinpoint that to an exact location. But actually this is impossible. What you're really doing is measuring a smudge of locations. And it's the size of this smudge, which is known as the uncertainty. When that smudge is larger than the object itself, that's when you find that the object can be in many different positions at the same time. And this is known as Heisenberg's uncertainty principle. When we experiment with the smallest of objects, such as electrons, we begin to deal with something which actually has a really large uncertainty. And it's fundamentally because it's physically smaller than the wavelength of certain sections of light. It's often why we describe electrons in really vague ways, such as being an electron cloud or electron orbit. It's because its position is actually in many different areas at the same time. And this produces some really weird behavior, such as quantum tunneling. This is basically like an electron reenactment of the Great Escape. So when the electron is faced with a barrier that doesn't have enough energy to climb over, it simply tunnels through and appears on the other side. It's like the electron wants to be like Steve McQueen, but can only pull off a Charles Bronson. And the only reason for this is because its position is so uncertain, it can be in many different locations. One location just happens to be beyond that barrier. Sounds really strange, but it happens all the time, every day, in your TV remote control. So there's a diode inside which sends out a signal to your TV every time electrons tunnel through a semiconductor layer. Unfortunately, quantum tunneling isn't the reason why your TV remote ends up buried at the back of the sofa. Different type of tunneling altogether. So the question is, since humans are made up of atoms and electrons, could we tunnel through a wall? Well, the math says it's not impossible, but it's highly improbable. This is because your smudge of locations has a probability distribution. So there's a central bright spot where it's most likely the atom will be, and then a fading edge where the probability decreases dramatically. So the further you want your atom to tunnel, the less likely it will happen, which just means the more repeats and runs you have to make and the longer you have to wait. Essentially, if you wanted to just appear on your side of a wall, you'd have to run repeatedly into that wall every second since beginning the universe until now to maybe see one event, which really isn't that worth it since we have perfectly good doors anyway. Thank you.